Hello students, in this video I would like to discuss about quicksort. So quicksort follows divide and conquer approach. Quicksort works by partitioning the array into two pieces. Two pieces are separated by a simple element x called pivot element. Pivot element x is greater than every element in left piece. Pivot element x is smaller than every element in right piece. This guarantees that pivot element is in its correct position. Then the algorithm proceeds by applying the same method to two pieces separately. Procedure partition a, p, r separates array based on pivot element and return its correct position. Any element in the array or piece can be considered as pivot element. Here we choose last element in the piece as pivot. So here in quicksort it follows divide and conquer approach, and also the key procedure in quicksort is partition a, p, r. So let's look what this procedure do. It will choose last element in the array as pivot. Then it arranges the array in such a way that the pivot element will go to correct position. And also what it will do, all the elements which is lesser than the pivot element will be placed in the left piece, and all the elements which is greater than pivot element will be placed in the right piece. So the same procedure will be applied separately to this left piece and right piece. So it will be done recursively, and after some point we will get the entire array as sorted. So here the key procedure is partition. So here's the pseudocode for partition procedure. So it has three parameters a, p and r, which separates array based on pivot element and returns correct position of pivot. So I will try to explain the partition procedure with the help of an example. So here I have an array of size 8. Here also the index value is starting from 1. This 0 is just denote the initial value I is actually 0. The array starts at index position 1. So just imagine I have a call partition a, 1, 8. So what will this partition procedure do? Separates array based on pivot element and return correct position of pivot. This partition procedure actually returns some value. What will be that value? It will be the correct position of pivot. So here p is 1, r is 8. But the first line, x equal to a of r. What is a of r? 44. So x equal to 44, that means 44 is the pivot element. Then I equal to p minus 1. P is 1, so I is 0. Next I will have a for loop. The for loop will iterate for j values p to r minus 1. That is, when j equal to 1 to 7, this for loop will execute. P to r minus 1. R minus 1 is 7, 8 minus 1, that is 7. So this for loop will execute for j values 1 to 7. So initially the value of j will be 1. This condition will be tested. What is a of j? A of j is 22. 22 is compared with 44. 22 is less than 44. So these two statements will be executed. It's worth noticing this line number 7 is actually outside this for loop. So anyway, here a of j, that is 22 is less than 44. So these two statements will be executed. I equal to I plus 1. So I value becomes 1. Then what will I do? I will exchange a of I and a of j. That means this 22 is swapped with the 22 here. So 22 will be here. Next the for loop will execute for j value 2. Now j value becomes 2. Next I will compare a of j and x. Here a of j is 88, x is 44. The condition is false. So it will not execute these two steps. So the for loop will execute for next value of j. So j value will be incremented. Now j value is 3. Next a of j and x will be compared. A of j is 77, x is 44. Again the condition is false. So these two statements will not be executed. Then j value becomes 4. Now j value is incremented. Again the condition is tested. 11 less than 44 is true. So it will execute these two lines. So now I value will be incremented. Now I value becomes 2. Then I will exchange a of I and a of j. So this 88 and 11 will be exchanged or swapped. So 11 and 88 are swapped. Again j value will be incremented. Now j value becomes 5. Again the condition is tested. A of j less than x is 33 less than 4, that is true. So these two statements will be executed. I is incremented and it becomes 3. Then what will happen? The 77 and 33 will be swapped. Now 33 and 77 are swapped. Next j value will be incremented. J becomes 6. Here also 55 and 44 will be compared. 54 and 44 will be compared. That is false. So it will not execute these two statements. So it will execute for next value of j. So j value becomes 7. This condition is checked. 66 less than 4 is false. So it will not execute these two statements. Now the value of j is 7. That means j reached r minus 1. So this for loop execute only up to r minus 1. So this for loop will not execute anymore. So the line number 7 will be executed. A of I plus 1 and A of r will be swapped. What is A of r? A of r is A of 8. A of 8 is 44. 44 and A of I plus 1 will be swapped. What is A of I plus 1? I is 3. A of I plus 1 is A of 4. That is A of 4, 88. This 88 and 44 will be swapped. So 88 and 44 will be swapped. Then return I plus 1. What is I? 3. So the procedure will return a value 4. So that's the end of partition procedure. So now what happens? Actually our pivot element was 44. The pivot element is fixed at its correct position. You just imagine this, when list is sorted, this 44 will be at the 4th position. So this is fixed. And also one more thing is happened. The elements on the left hand side of 44 is less than 44. 22 is less than 44. 11 is less than 44. 33 is less than 44. Similarly, the elements to right of the pivot element 77, 55, 66, 88 are greater than 44. So now what will we do? We will apply the quicksort procedure to this part, that is left piece, and also we are going to apply quicksort procedure to this right piece. And I hope you understood this partition procedure. Let's move to quicksort procedure. So this is a quicksort procedure. Here also we have 3 parameters: array A, P, R, and also you notice the initial call, that is quicksort of A, 1, n. So if it is n elements and also our array starts at index position 1, our initial call will be quicksort of A, 1, n. So P less than R. Anyway, just imagine 1 is less than n. So first it will execute this partition procedure. So you already see the partition procedure. In our example, the Q value returned is 4. Then I am applying quicksort here. A, P, Q minus 1. P is 1. Q minus 1 is 3. That is, we are going to apply quicksort procedure in left piece. Here quicksort of Q plus 1. That is 4. That is P value is 4 and R value is R. So Q plus 1 is 5. Here in the right piece also I am going to apply quicksort. So this procedure will be executed recursively, and in the end we will get a sorted list. The analysis of quicksort will be discussed in the next video.